Hi everyone, welcome to this week's Scrum meeting. This week I mainly focused on the training process of our neural network model, incorporating strategies to enhance performance to prevent overfitting. I initiated the training loop by setting the number of epochs to 100, allowing the model sample the model ample opportunity to learn from the data. However, to avoid overfitting, we implemented an early stopping mechanism with the patience of 10 epochs. This means that if the validation loss does not improve for 10 consecutive epochs, the training halts, preserving the best performing model states observed thus far. And after each epoch, I compared the current validation loss to the best loss recorded. If an improvement is observed, I updated the best loss and reset the patient's counter. Throughout this training process, I logged the training and validation loss for each epoch. And also by integrating early stopping, I ensure that our model achieves optimal performance without unnecessary training, maintaining a balance between learning and generalization. Next week, I will focus on evaluating the model and implementing cross-validation. Thank you. And I will hand it to Xiaoyi.
Thanks, Chenxi. Good evening, everyone. This week, I focused on deepening my understanding of DNN and began exploring PyTorch for deep learning. For DNNs, I continue studying their theoretical foundations, particularly how they use layers to automatically extract features and capture complex patterns in data. This theoretical knowledge is critical to understanding why and how DNNs outperform traditional models for high-dimensional or unstructured data sets like images or texts. In addition to studying the theory, I started learning the functionality and syntax of PyTorch, one of the most popular frameworks for implementing deep learning. Uh, in particular, I familiarized myself with key concepts like tensors, building neural network layers, and leveraging PyTorch's dynamic computation graph for flexibility in model design. I also experimented with basic operations to get a feel for how PyTorch simplifies deep learning workflows, such as training and backpropagation. Looking ahead, my goal for next week is to implement a basic deep learning model using PyTorch, building on the theory and skills I've developed so far. I will also aim to optimize the model potentially by experimenting with hyperparameter tuning or trying different architectures. Since this is my first time working with PyTorch and DNNs in practice, it will be a learning process, but I'm excited to take this next step. That's all for my part. Next is Xiaoyu.
Thank you, Xiaoyi. Hello, everyone. So this week I focus on deepening my understanding of PyTorch, particularly how it can support our project goal. So far, I have been explored the basics of neural network implementation in PyTorch, which has helped me understand how the structure models with layers and activation function. I also implemented logical regression in PyTorch, which gave me hands-on experience with the model setup and training process in the library. This is critical because it's aligned with our use of logical regression in the project. But now with the flexibility PyTorch offers, currently I'm learning about approach for creating tree basics structure in neural networks. Although PyTorch doesn't directly support decision tree, I'm studying differentiable tree models, which might help us apply tree-like interruptibility within a neural framework. Additionally, I'm exploring cross-validation techniques for deep learning, which is directly relevant to our project's goal of ensuring model reliability and generalization. Those learnings are important because they bring us closer to applying advanced modeling method while enhancing model generalization and robustness, aligning well with our objective of improving predictive performance. That's all for my part. And next, let's welcome Tianyi to introduce her.
Thank you. Thank you, Xiaoyu. So this week I started on the next phase of our project, transitioning the KNN and logistic regression models into neural networks using PyTorch. This change enables our models to learn more complex relationships within the dataset and potentially improve prediction accuracy for heart disease. For the KNN-based neural network, I'm working on building a model with several hidden layers and dropout to simulate the effect of similarity-based classification that KNN offers. This structure will allow us to capture important neighborhood relationships in the data, but with the flexibility of a neural network. For logistic regression, I'll keep the architecture simple, using a single output neuron with a sigmoid activation to maintain the binary classification framework. This setup will provide a baseline comparison to see how neural networks handle the prediction compared to traditional logistic regression. Currently, I'm focused on structuring these networks, defining hyperparameters, and ensuring proper loss functions and optimizers. In the next couple of weeks, I will work on training these models and fine-tuning them with cross-validation to ensure accuracy and generalizability. With this process, I am hopeful we can leverage the strengths of neural networks to gain more robust predictive performance in our heart disease model. So that's all for my part, and I'll pass it to Jalen.
Hi everyone. This week I dedicate my time to building and fine-tuning a deep learning model to predict heart disease. Starting with the basic neural network using TensorFlow and Keras, I initially reached about 85 85% text accuracy. I wanted to push that higher, so I focused on improving data pre-processing, feature selection, and model architecture. Uh, for pre-processing, instead of dropping missing values, I kept more data by inputting values with the median and handle class imbalance using smokes. On the optimization front, I added layers and job out to prevent overfitting, applied regularization, and fine-tuned hyperparameters using bias and optimization. I also used early stopping and learning rate to scheduling to improve training efficiency, which brought the model's accuracy up to around 90%. Looking ahead, I also consider gather more data or adding features to help push the model's accuracy beyond this current level, and maybe consider using the cross validation to validate the final result. And that's all for my part for this week. Thank you, guys.
Thank you,
Thank you.
guys. See you next week.
See you next
So,
week.
Good night.
bye.
Bye bye.